All right, a couple things I want to cover today. One is the idea of generics, which are what are known in C++ as templates. And the idea behind a generic is you've seen this syntax in a couple of places now, right? Where we did array list and, oh, I want an array list of integers. Is equal to new array list like that, right? We've seen that. This is what's known as a generic, because we could just as easily create another array list with another data type in there, right? And so we've seen that syntax, I don't know what variable names I'm choosing, in a couple of different places. We can use that idea ourselves because there's nothing, magical that gives Sun the ability to give us classes like that we can't use. So the way that looks, and we saw that with stacks as well. You want to create a stack. Just say you have a data type called point. Here, now we have a stack of points. And so on. So this can be any reference data type. It just can't be a primitive, right? So if you want to use integers, you can't use int. You have to use capital I integer. And floats, you have to use capital F float, and so on. So it has to be a reference type, a class, not a primitive type. This is class 216, is it not? Pardon me?
2613. What are you talking about, the classroom?
Yeah, the classroom.
Oh, 218.
Yeah, 218. All right. We'll have another student showing up. Okay, so the way that works is you use a syntax like this with these angle braces inside the declaration of your method or whatever. Let me get my example up here. So in order to support the ability to specify, the type of data being passed into it, why would you do that? Because you wouldn't want to create 20 different array list classes, one for integers, one for strings, one for floats, one for doubles, because then it wouldn't be expandable with your own reference types. Yeah. And we've seen the idea of overloading, I believe. We talked about overloading. Please tell me we have we not? All right, so the idea behind overloading is you write a method that has the same name but different data types. So you could write a method called, public void say hello, and it took one name. And then whatever it was going to do there, right? System.out.println name, hello name, whatever, And then you could write another method with the same name but different data types. So whatever our class was. These would have to be static if they were going to be called by the main method, in the same class or whatever, but that's not really the point of it. So say we wanted the ability to pass in two names. We would provide another method with the same name. So first name, comma, string last name. And then when we said hello, we'd want to print their first name followed by a space. Oh, and I forgot to put a space there for niceness. But anyways, first name followed by a space followed by the last name. So that's overloading. So later on in our code, if we wanted to say hello, we could either do this, say hello, Joe. That'd work great. Or we could do say hello, you know, Johnny Johnson. Well, but let's put them in separate, you know, Bob, comma, Roberts, like that. We could overload it with as many different data types as we wanted, as long as their header signature is unique, meaning that you couldn't create two overloaded versions that just had the same data type but different data variable names, right? If, say I went and I added one more say hello, and for some reason I thought it should accept a name, excuse me, a string, but it was something other than a name, right? String position, like, you know, director or, you know, whatever, president. So this would not work. Why? Because the compiler has no idea which one we would be calling when we did that, right? Because the way it references it, the way the compiler stitches it together, is it looks for a method with that name, and then it looks at the parameter list, and oh, this is a string, I better find the one that accepts only one string. And then go up here and okay, well that's great, but no, actually would not have compiled because there's no way for this one to distinguish whether it was supposed to invoke that one or that one. So the parameter list signature has to be unique. And by signature I mean the types. You can't have the same number, you can't have the same data type just with a different name if that's the only difference. So it has to have different numbers of parameters, or if it has the same number of parameters, they have to be of different types. So that's overloading. Overloading is not a bad thing. It's not like the engines are being overloaded. It's going to blow up. So an example of that is you could have a function called add that took two numbers. I'm going to call them n1 and n2. And it would return n1 plus n2. And then you decide, well, gee, I really would like to be able to add three numbers as well, and then 4. So int add, int n1, int n2, int n3. Do the same thing. I should just cut and paste it because I know that y'all aren't necessarily typing along with me. n1 plus n2 plus n3. And then one more, one that adds 4 values together. After this point, it starts to get a little bit silly. You know, am I going to make one that takes 5, 6, 7, 8, 9, 10? There's better ways to handle that, like passing the data in as an array or something like that. But that way, when we were ready to use it, we could do this, right? X is equal to add 1 and 2. That's great. Or X is equal to add 10, 20, and 30. That's cool. X is equal to add, you know, 5, 6, 7, 8. That way. Same function name. That's a lot better than writing one function that says add 2 because it adds 2 numbers, and writing another function, another method named add 3, and another method named add 4, right? That way, you know, makes it more flexible. If we want to go in and write another version of it that accepts floats or doubles as well as, you know, ints, we can go and add those as well. Right now, this doesn't accept, you know, doubles. So we could overload it with another data type, but it would have to return a double, right? Because if you're going to add doubles, then you'd want to do a double. So, you know, double add double, you know, D1, D2. And then still just return D1 plus D2. So then when we wanted to, we could also call X is equal to add, you know, 1.0 and 2.2. Whatever, you know, that way. Same method name. Makes the code easier to read, makes it easier to maintain if you make methods that support different data types. If you ever find yourself wishing that you had a different version of the method that accepted a different data type, don't make a new method name. See if you can do an overload instead. Now don't go nuts. Don't go, okay, well I'm going to write a version of add that accepts floats, and I'm going to do one that accepts longs, and one that accepts doubles, and one that accepts ints, and one that does shorts, and one that, you know, oh, and what if they pass in a double and an int, and, you know, and I'm going to reverse the order. Don't sit there creating hours of work for stuff that, you know, you're not going to use, or that somebody else wouldn't use. There's a tendency in programming for people to over-engineer things. And yeah, you want to make an elegant program, and once you get use of an idea, you feel like you ought to use it, but then you can go overboard in using it. And you'll see that a lot of that in class development, especially when you're doing C++ programming and you learn the idea of operator overloading. So that is the idea of overloading. Overloading is offering multiple methods with the same names but different parameter lists. You could write a version of add that converted things to strings before it added them together. Let's do another one. Double add, and it takes string S1 and it takes string S2. And here's what it's going to do. It's going to convert those values to doubles and then add them together, right? So double D1 is equal to, we'd have to convert it, double dot parse double that string. The same for the next one. Double D2 is equal to double dot parse double string 2, right? And so now we have two numbers, so we can return D1 plus D2. So we felt like adding two strings together. X is equal to add, 1 and 100. Whatever, like that. Gives you flexibility. Is there a reason we haven't talked about that yet? Okay, so back to the idea of generics. If you're going to do a generic, then when you define your method, you use that same syntax. The angle braces. So what if you wanted a method that would pretty print out an array? Maybe, listing the index number followed by the value. And you didn't want it to care about what kind of array you were passing it. You didn't want to write one that would print, an array of strings, and another one that would do an array of doubles and stuff like that. We may as well actually do this one in NetBeans. So I'm going to create a daily file. So what I'm going to do here in main is I'm going to write a method that uses a generic. And since I want it to be able to be called by main in the same one, I have to make it static as well. So public static, and E is going to be the name of our generic type. Now that E is not fixed and sewn. You could call it anything you wanted to. You could call it Fred. But the canonical way of naming them is to call it E, an uppercase letter to show that it's a generic. If people see this kind of nomenclature here and they see an uppercase letter there, they know that, that you're creating something that does generics. Okay, so the name of our method is going to be called printArray, and it's going to take an array of type E. You see, just like that. So if we build something that says integer there, then when this is created, it's going to do an array of integers there. And I'm just going to call my array AR. And I forgot to declare it as void. So public static void. There we go. And I've put this in a something's bugging me here. I'm not going to declare that as void. And it's going to yell at me that I did not. I've done something wrong. I may punt on this if I can't get it to work. Alrighty, so we would just do a for loop. We know we have an array. For int I is equal to 0, we could do a for each, but I want my index counter. I is less than ar.length, I++, and let's print out each element of the array. Oh, the void does need to be there. Why did I take that space away? Okay, there. That was my mistake. I accidentally had deleted the space between the word void and array. Okay, so we're going to system.out.printf. Let's assume that our arrays are always going to be less than 100. The index value followed by the array value. So percent 2D. If I thought I'd go into the hundreds, I'd make it percent 3D, so I'd have 3 places, is equal to percent %s \n, comma. Now let's print out the index, and let's print out that array element at that position. All right, let's test it out. Down here in main, I'm going to create an array. How about an array of strings? Good old colors array. String, square braces, and then the array name colors is equal to, and let's just use an initializer list to put some colors in. Red, end quote, beginning quote, blue, end quote, beginning quote, green. And let's make another one full of integers. But generics cannot be primitive, so I can't just do an array of ints. It has to be the wrapper class. So integer nums. And I'm not sure why I made my array name uppercase. I'm going to take that being lowercase. And let's put some numbers in there. 1, 3, 6, 2, whatever, you know.
Does it matter if it's uppercase or lowercase, or it's just easier?
It does. All identifiers should start with a lowercase letter, but that's just a hint. Yeah. Yeah, that's a stylistic thing. Generally, the rules are variable names and methods should start with a lowercase. Classes should start with an upper. But okay, so let's print them out. What's the name of our function? It's called... Oh, I wanted to come up with a better name than just array. How about print array? So I'm just going back up to my static method up here, and I'm calling it print array. Or maybe I could just call it print. Yeah. Okay. So I changed that. The word array was stupid there. Now it's the word print. So now down here, when I'm ready to invoke it, I do this. And again, that should have been lowercase. I've been doing C# recently, where a lot of folks do the uppercasing of the first letter. It's burnt my brain. Okay, so we're going to print the colors list, and we're going to print the nums list. Okay, so this is an example, or I'll go ahead and put my comment here. Print is an example of defining a method with a generic. Specifies the data type. So the E specifies the data type, and then you use E in your method parameters, or wherever you need to declare. And again, it doesn't have to be E. It would work just as well if we called it F, or if we called it Barney the dinosaur, or whatever. I guess I never tested it. this loaded up. Why have we not covered overloading yet? Part of chapter 7. What have we done with chapter 7? Alrighty, did we give short shrift to chapter 7? I'm going to have to go back and look at what we did. That could be. Okay, so anyways, here we are talking about using generics. But I know we've done constructors, right? And we know what class variables and class methods are and how to access them and use them. But I do see some stuff that I don't remember us hitting. So we are going to go back and hit chapter 7. So I said I wanted to cover 2 things, and generics were one of them. You can also create generic classes. And the array list is an example of a generic class. Let's create a generic class. You know, the array list lets you create, an array list of integers or doubles or floats or, points or whatever. We can do the same thing. I'm going to go and create a class that accepts a generic as its constructor. So what I'm going to do is and let's just call this one box, because it's going to hold a single value. And we're going to make 2 methods, a put and then a get. So you can put something in the box, you can get something out of the box. But we need a variable to store that in. That's the item that's in the box, the value that's in the box. So let's do the put. It doesn't need to return anything, so it's going to be void. Oh, by the way, I've already made a grievous error. Does anybody see my mistake? My broad philosophical mistake is I shouldn't be putting multiple classes in the same file. But if I'm going to do that, I've made a mistake, which is you can't have 2 public classes in the same file. You can only have 1 public class, and that is the one that matches the file name of the class name. So if I was being a good boy, I would take this class and I would move it into its own. Okay, so put takes a value of that type and sets it. So this dot value is equal to the value that's popped in there. And now let's write a get. That'll return it. Now the get is going to return the value of that same type. So public E get, and we're going to return this dot value. It'd probably be more fun if we wrote a point class like this, so that you could, hook up two integers together or 2 doubles or whatever. I think this will be enough for now. Alrighty, I'm going to cut this and I'm going to paste it right above my main so that I can then use it in my main. Did I ever even run my code to see if it worked? Why don't I do that? No, I can't cut it and paste it above main because it needs to be a class. Well, I did say that you could put classes in all sorts of strange places, but anyways, run it. All right, it did print out my 2 arrays. using my special little print method. How about using the box? Has everybody got this typed in? Go ahead and get that in. Remember, it needs to be above the other class if you're putting it in the same file. Otherwise, make a new file, a box class, and put it in there. Now let's go down to main and use it. Let's make a new box. We're going to make a box that contains a string. And so I'm going to call it a string box. Is equal to new box. And in my string box, I'm going to put a word, whatever word. Testing. Now if I want to get that value back out, string s is equal to string box dot get. And we can print s out. System dot out dot print line s, or string box contains plus s. So all of your major object-oriented programming languages will have variations of this. Like I said, C++ calls them templates. I forget what they're called in C#. Java calls them generics. It just means that you get to write either classes or methods that'll work with a large variety of data types and not just one. Of course, you have to do some, these are deliberately very simple versions, right? So you may... Usually it would be a little bit more complex because you wouldn't just, be getting a number out and putting it back in. Let's run it and see if it works. Alrighty. The string box did in fact contain testing, although I should have put a space there when I was printing it out. Alright, I'm going to paste this code. Into our notes right there. Example of using generics for a class. An example of using a generic for a method. So the reason I wanted to hit on that is because for a couple of weeks now we have been using that angle syntax, and I didn't want it just to be a magical thing, A lot of syntax you just have to accept. Why did they choose to put, curly braces here when in Python you would have used, square braces to define your initializer list? Well, you got me. But in this case, we can figure out now what that means. And it means that when you create the class, when we say we're doing a box of strings, and then we go and look how the class is defined, see the class is called box, and then that word string fills that in. So that everywhere else, that gets expanded to string when it is compiled. Alrighty, we've talked about stacks. We've talked about queues. Which one, stacks or queues, are last in, first out? The last thing you just added to it's the first thing you take out of it.
So keys first thing?
Yep. Queues are first in, first out, just like people lining up to get into the theater. So queues are first in, first out. Stacks are last in, last out. And then, you Python programmers are aware of the idea of dictionaries. In Java, they're known as maps. Same idea though, they just map one element to the other. And so maps are incredibly useful, just like dictionaries are incredibly useful. Anytime you have pairs of values that you want to tie together, you can use them with a map. It's really bugging me, though, that Chapter 7 stuff that is seeming like we may have skipped. I guess we'll go ahead and finish using the maps, though. Broadly speaking, there are two kinds of maps. You know, the collections framework is vast and contains all sorts of permutations, but there are sorted maps, and then there are unsorted maps. Python doesn't have that distinction, I believe. A sorted map goes to the trouble of making sure that everything you add to it is sorted if you iterate through it with a for each, right? So it'll be all sorted by its key. But an unsorted map, you know, a little bit faster, you get the performance gains of, you know, when you add items to it, they're not indexed. So you have no idea what order they're going to be in. So a map ties a key to a value. And as part of the Java collection framework, along with array list and the rest of them. So we have sorted maps, and when I said that there were another kind called unsorted maps, they're calling that a hash map. And honestly, I don't know what a linked hash map is. I'd have to go and Google the difference between a hash map and a linked hash map. So a map relates an object to another object. So it's like a mathematical function. You put in a key and it returns a dependent value. And you build it. You know, you add things to the map. You give it, you know, okay, I want to associate my first name and my last name. So, you know, into my map, add Jeff Thompson. And then add into my map Mickey Mouse. And then when I want to know my last name, I ask the map for my, you know, what is Jeff's last name? Well, my first name's Jeff, so it pops out Thompson. What is Mickey's last name? I access the map, you know, I get Mickey, and it'll return Mouse out of it. So you define a map the same way that we have been doing our array lists. I'm going to use sorted map, just in my little example. So sorted map, and then you have to give two types, the key type and then the value type. And then you give, you know, the map name is equal to new, you know the rest of this just based on our experience. Like that. That would create a map. It's an empty map right now, but it's set up so that you can add key value pairs to it. So for example, suppose we wanted to correspond people's names with their ages. So you could do sorted map, a string that hooks up to integers, and I don't know what we're going to call this, age map is equal to new sorted map, and I did that wrong. It's not double, you know, like that, because you only have, that's how you define your generic for both of them. And if that's not the case, we'll find out very soon. Then I would start putting things into it. AgeMap.put. All right, Jeff is 23 years old. I wish. AgeMap.put. You know, Mickey, pretty dang old. Mickey's 105 years old. Now, if we want to get that value out, we can do so. We want to find out, you know, how old Jeff is. Pretty easy to do. Instead of using put, we use get. So, int Jeff's age is equal to agemap.get for Jeff. And int Mickey's age is equal to agemap.get, you know, for Mickey. Now this is implying a unique key, though. if we add another value for Jeff, it's a one-to-one correlation. So if I went and then turned around and I did another put for Jeff, and I said that Jeff was really 40, well, this one's gone now. We've replaced it. Just like if you take a book out of a library and you know, scribble all over the pages, you put it back in, it's changed now. It no longer is a 23, it's a 40. Let's play with that in our code. Like, I don't know, maybe authors and books. So SortedMap, you know what, I am going to do a Java doc on that to make sure that I'm declaring them correctly. Well, that didn't work because I don't have the right import for it yet. Yep, just like that. Okay. Alrighty. So we're going to do a sorted map. We're going to call it library because we're going to correspond books and authors. So we need to specify the generics. They're both strings. So string comma string is equal to new sorted map, angle braces, parentheses to invoke the constructor. And I'm going to have to add an import for the sorted map. And it's telling me that sorted map is abstract, cannot be instantiated. Yippee, I've forgotten a little. Okay, that's TreeMap. Sorted type is an abstract class, and TreeMap is one of the implementations of it. So excuse me, TreeMap. And I'm going to have to add the import for that too. And I'm going to have to go and change my notes. Okay, so a map tie is a key to a value. To use a sorted map, we will use the non-abstract TreeMap class. So sorted map whatever is equal to new TreeMap. My guess is that I could make this say TreeMap as well and be just as happy. Yep, okay. All right, let's add some books to our library. Library dot put. And now, who wrote what? J.K. Rowling wrote Harry Potter. My mind always goes blank when I start trying to label off books or movies or whatever. So I'm going to just put another one, and I'm going to ask y'all to put in, you know, several. Just mix them up. Asimov wrote I, Robot. And Beatrice Potter wrote the children's book about the rabbit. Oh gosh, I cannot believe my brain just froze on the name of that rabbit's book. The rabbit book. It's like Peter Cottontail or something like that. I forget which one it is. Now, since it is a sorted map, we could iterate it through it with for each, and they would be sorted by their key. So Asimov would be first, and Potter would be last. If we had created an unsorted map, then they wouldn't be. And frankly, unless performance was my arch critical concern, I like sorted maps just because if you ever, you know, print them out for debug purposes, it's nice to have them sorted in key order. But if you're never going to be displaying them, then it doesn't matter what order they're in, most likely. So I'm going to do a loop. the syntax is a little bit odd. For parentheses, map.entry, and we have to define our map.entry in the same format that we did the map itself, the key value pair data types. For every entry that's in the library.entry set. And I'm sorry, it shouldn't have been map.entry. We would have called it library.entry. TreeMap.entry. And I'm watching it. I'm changing it back to map.entry, and it's probably just something I should have included. Yep. Alrighty. So now that we have the entry, let's just print that out first. System.out.println. We're going to be getting all the keys this way. Key equals, end quote, plus let's break this out into two steps. String key is equal to entry.getKey, and string value is equal to entry.getValue. Now we have both the values we can play with. We can print them out. System.out.println. Percent, okay, I'm going to do a printf so that I can use my formatted print statement. %f wrote %s. \n, end quote, comma, the key and the value. And we could have given better names, right? I could have said that the key was the author and the value was the title. So in that case, it would say key author is equal to get key, and then key, title is equal to entry.getValue. And when I printed them out, I would, print, the author there and the title there. Let's give that a shot. Okay, but let's say we hate science fiction and we want to remove iRobot from our list. You just call .remove. So before I print it out, I'm going to call .remove. Library.remove Asimov. All right, and so since we only have 2 books in our library now, we have J.K. Rowling and we have Beatrice Potter. All right, maps are incredibly useful. If you get into a mindset of, well, I can't make you write program after program after program that uses maps. Hopefully I'll have an assignment that uses them, and we will come back to the topic again at least once more. Is it working for everybody? Okay, good deal. So up at the top of our code, we had to have some imports. This is for the folks who are playing along at home and they can't get your code to work. We had to add those imports. And then this is the code we just typed. We created our tree map. We added a couple of things. We removed them. Then we have a for loop that prints them out. And I apologize for this syntax being a little bit odd. But we have a ranged-based for loop here that uses a class called entry, map.entry. So you can be sure that the entry class is a class that's nested within the map class. Can I do a show Java doc on that, please? Yeah, interface map entry. Okay, now we're going to put our thinking hats back onto writing classes and constructors and their type. So what happens when you create an object like that? Well, that doesn't create the object. That just creates an address in memory that can hold a reference to an object, and a reference to an object is another address in memory. So this creates a reference to a car. It's just a place waiting for a car to be put into it. And then we create the car. This goes out into another area of memory called the heap. Nope, called the stack. I was right the first time, the heap. And constructs the object and returns the address of it, which is then stored in the reference. So now we have a little bit of memory that can hold, that's large enough just to hold a memory address right there after that code executes. When this code executes, a whole bunch more memory, however large it requires to actually hold a car object, is allocated. And the address of that space is returned and then put in that variable. Then every time we want to reference it, we use the object name followed by the member, the method of the variable that we're going to use. You can have multiple object references pointing to the same object. If you do something like this, say you have a car class just like that's showing. Car C1 is equal to new car. And then you have car C2 is equal to C1. We now have two references to the same car. So if we say C1.model is equal to, make is equal to Ford, then C2.make will also equal Ford at that time. When do objects get deleted? When they fall out of scope. Say we do this. Car C1. And then inside some block of code, like an if statement or a while loop or something like that, we actually created a car. C2.color is equal to red. Then when we try to get down here, this object has fallen out of scope, right? C2, unavailable to us. So we can't get the color of that car out. That's pretty obvious. But what if on our way there, before we left that block of code, we did this, C1 is equal to C2. Then by the time we get here, could we print out C1.color? And the answer is sure, we can. Why? Because we have a reference to an object, but this copied that address, that reference, into another variable. Now we have two references to it. When we fall out of scope, this variable disappears, and so now we only have one reference to that object, but we do still have one reference to it. And it's not until this closing bracket is found that there are now no references to that object. So if this was inside, another code block for some reason, and this is legal, you could, use braces like this to differentiate parts of your code if you wanted to. It's not until this brace here that the object is completely destroyed. And that's the wrong way to put it. It's not until this point right here that we don't have any references to the object anymore. Once you don't have any references to the object, it's called an orphan object. And it's still taking up memory. But the Java garbage collector is supposed to notice that and then free up that memory. And that's a different approach than how C++ does it, where you have to write destructors for your code, as well as constructors. So here's another example of an orphan object. What if I have some code that looks like this? Car C1 is equal to new car. And then I say C1 is equal to a different new car, right? I set this car's color equal to red. But then I created a new car and set that one's color equal to blue. What happened to my red car? Can I get to it anymore? No, because I no longer have a reference to it. This replaced the address with a new object. But that old object is still out there in memory somewhere. Somewhere out there, there's still a red car. But it's now an orphan object. There's nothing pointing towards it. We have no references towards it. And as soon as the garbage collector notices that, it's going to release it. This kind of stuff really most matters in loops. Because if you have some code that's allocating objects and never releasing them, then as that loop executes hundreds of thousands of times, then you're relying upon the garbage collector to try to clean things up, and it possibly could run out of memory. I don't know how to expand upon that idea. Just be cognizant of the way the objects are destroyed. They're destroyed when things fall out of scope and when it has no more references to it. But that's not an automatic process. It's not instantaneous. So what if I did have a loop? I might want to find a way to reuse the same object over and over and just change its attributes each time. Right? If that loop's going to run 100,000 times in a row, if I can just create one object and then change its attributes, rather than create 100,000 different objects, and hope that the garbage collector cleans them up fast enough that I don't run out of memory, then that would be more efficient. Because each time you create an object, it has to go and allocate new. Another place where that becomes important is when you're using recursion. And if the recursive function is creating an object each time it gets entered, then by the time it's called itself 100 deep, then you have 100 objects sitting there waiting to fall out of scope. And they can't start falling out of scope until it starts coming back out of the recursion. So you can absolutely have two references to the same object. Is that a good thing? Well, you're going to create an object and then you're going to pass that to a class. And maybe that class is going to store a reference to that object so that it can keep working on it. That becomes problematic. That's kind of a lecture I need to give. Let me make a note of that. Lecture about using references versus copies when passing an object to a class. Okay. If you actually want to copy the variable, make a new object that has, all the same contents as the original, how would we do that? I'm pretty sure we've talked about writing a method that constructs a copy. We did dot equals, right? You use a method called dot copy of, or you overload a method called dot copy of. So if you're testing two objects for equality, we know this. You can't just use equal equal. You create two strings, you want to see if they have the same content. You can't just do if string 1 equal string 2. What do you have to do? So this is bad writing here. What would we do to compare two objects? What do you do to compare two strings? String S1 is equal to Bob. String S2 is equal to, scanner dot get line, next line. You want to compare them? Do you do this? If S1 is equal to S2. Is that a valid way to check them? Yeah, you can tell by the way that I'm asking the question. The answer is no. And why is that? Because these are just references. S1's got a memory address in it. S2's got a memory address in it. All this does is check to see if they're pointing to the same memory address. Yeah, if they are pointing to the same memory address, great, right? But you could have two different strings, that are pointing to two different memory addresses that have the same contents. Like what if the user types in Bob? Then S1 and S2 are going to contain two different addresses. And this doesn't check the contents. It just checks the addresses themselves. So this would never turn out true, no matter what they typed. So that's not how you do it. Instead you use dot equals. If S1 dot equals S2. Then you could do something. And what does that do? That invokes the dot equals method of the string class. The dot equals method iterates through both strings, seeing, by value, seeing if they match or not. So when we wrote our classes, and I think that we ought to write a couple of more, you implemented a dot equals method to compare, the contents of them. Right? We've had homework like that. Right? I'm seeing some heads wobble left and right. Maybe we have, maybe we haven't. Maybe it's just been too long. Let's go look, and then we'll make a Dropbox and kind of be done. But I thought.
I know so much. I just want to erase.
Yeah, this was back in February. We probably did too much on arrays. We need to go back and hit chapter 7 hard. I don't know what happened to my brain. Let's go see what the assignment was.
I wish I knew yesterday.
Okay, so modify the class to compare the objects to see if they are equal. And so to do that, we add a equals method. We better do it again, though. All right, so we're going to tackle chapter 7 as though it is pretty much fresh material. I'm getting the idea that I just started hitting it and then we jumped from that to arrays. Now arrays are remarkably important, so I'm glad I do not begrudge the amount of time we spent on them. But we got to go back and hit this stuff. Alrighty, let's make a Dropbox for what we did. In summary, we talked about generics and we talked about sorted maps implemented through the TreeMap class. There are also unsorted maps, which are called hash maps. If you don't care about the order, the way you use them is exactly the same. It's just that when you use that loop to pull the items out, then they don't come back in any particular order. So we will go back and hit chapter 7 hard. In this lecture, we talked about generics and tree maps, which are sorted maps. So there's probably a quiz on chapter 7. I'm obviously going to open up all the, they said that they were needed to be done by
March
18th or something like that, but I'm obviously going to reopen them. I have graded the ones that have been turned in.
I was going to say, so the ones that were turned in, the graded ones, since we have more attempts, could we see what you graded and then honestly go back and do it again?
Do you mean, are you allowed to look at what you got wrong?
Yeah.
Yeah, you should be able to. Let me make sure that the settings for that are set. If not, that's bad.
Oh, you can.
Good. It doesn't show you the answer, but at least it shows you what's wrong, and I may have typed in a hint. All right, there's a Dropbox J for your generics and your TreeMap example. As far as homework is concerned, we have stuff queued up all through the end of the month, so I'm not going to add anything on right now.